Find out a couple of things so I can try to gauge the knowledge level of the audience. How many people out there know and are using COM right now today? Cool, cool, way cool. And for answering, you're gonna win a cool COM Plus resource CD. Limited edition, only 10,000. Some of my cohorts got a whole stack of them in the back, so please pick up a COM Plus resource CD before you leave. It's got a bunch of presentations, PowerPoints, transcriptions, additional resources for COM and MTS development, COM Plus development going forward. Ask for it by name. How many people are using MTS today? Man, that's way cool. I am Frank Redmond, and I will be trying to provide a basic understanding of what COM, MTS, and COM Plus are. As you know, this is Microsoft TechEd 99 in case you were lost, and this is the Dallas Convention Center. The COM Plus vision is quite simply to make it easier to develop, deploy, and maintain component-based applications while continuing to leverage your current investments in COM and MTS. Okay, a lot of people have bet their business on COM and MTS, folks like yourselves, and we don't want that to go unrecognized. We don't want to leave you stranded. We're going to migrate that investment going forward. We're going to add some additional new services, make it easier to develop robust distributed applications. That's the vision. That's our goal. Let's kind of start with exactly what is COM Plus. I've heard it's everything from COM with a longer wire to, the kitchen sink. Essentially, COM Plus is a couple of things. Think about basic COM, right, which defines a conceptual model, right? Interfaces, co-classes, GUIDs, reference counting via add, ref, and release, interface navigation via query interface, right? The basic rules of engagement between clients and component servers. Right, that's what the conceptual model of COM defines. But there's also a set of underlying system services, right, that facilitate object registration, right, in the registry, location of objects, instantiation or creation of objects, then all the plumbing that provides interface remoting, the proxies and stubs, things of that nature. The system services plus the conceptual model is what defines what COM is. COM Plus is all of that, plus the Microsoft Transaction Server services, okay, to provide simplified server development, transactions, a new security model, and administration of components and component-based applications. Plus, new MTS-like services beyond just basic transactions. Services like queued components, events, load balancing, and an in-memory database. These are the four primary services that you hear about. There's also a bunch of other additional services that you can take advantage of when developing your distributed applications. But these are the four primary ones. You roll all of that up into a single programming model. Those of you who are familiar with MTS know that there's a slight difference in the programming models between COM and MTS today. COM Plus searches to unify that to a single programming model, which means single registration. Okay? No more mtx.exe registry hacks, okay, to get bootstrapped in the MTS space. A single surrogate, DLL host, no more mtx.exe. A single activation path. Now co-create instance will flow your object context for you transparently so that VB and VB script and Java languages can simply do new X, okay, to create objects and have the operating system have COM Plus automatically flow the contextual information of one object to the next, which means no more iObject context create instance, no more safe ref, a unified programming model. We're going to take a step back now and look at some of the existing MTS services that CommPlus incorporates, and we're also going to look at how CommPlus searches to improve on those basic MTS-like services that already exist today. We'll start with simplified server development. Okay, so to build scalable servers today, before MTS I should say, developers had to worry about a lot of issues: multi-threaded programming, concurrency, process management. They had to deal with semaphores and mutexes, and thread pooling, database connection pooling. And a lot of different things like this were the burden of the developer until MTS came along, and MTS really pioneered a path where the developers could focus on writing single-user, single-threaded applications. Then drop them into a magical runtime environment provided by the OS, MTS, and have the operating system provide the basic services necessary to scale up that component to be used in a multi-user, multi-threaded environment, and provide concurrency and pooling and resource sharing, as well as an attribute-based programming model that many VB developers are familiar with. Okay? Attribute-based programming being, I focus on the business logic of my components. Then at runtime, I can make administrative choices as far as the services that those components require. For example, whether or not they require a transaction or require a new transaction, whether or not they support transactions or not, the various people that can use that particular component in a role-based security model. Right? I can administer all those things administratively, and it takes the burden out of writing code. I can do a lot of those things administratively. That's the basic premise of attribute-based programming. CommPlus has taken another step in that direction, and going forward, we'll continue to try to evolve and promote this attribute-based programming model, as it allows you to concentrate most of your development effort in writing the code that solves your business problems. MTS also, since it's based on COM, allows you to write components in virtually any language. Okay? You can write components in VB, VJ, VC, a multitude of different languages, and use them all together to solve business problems. MTS also had pioneered the idea of packages, right, which going forward in CommPlus we'll call those applications. And it's a way to group components into a process. It allows me also to really easily deploy all of the client-side proxies and stubs and type libraries, all of the glue that's necessary for clients to bind to my object. I can package all of that up really neatly, making it easy for me to deploy my applications as well, with drag and drop simplicity. Microsoft Transaction Server obviously has transactions. We talked a little bit about the transactional attributes, and transactions solve a lot of hard problems in a distributed environment. They solve problems such as atomicity, right? Atomic behavior, having multiple discrete operations be performed as part of a single interaction, as part of a single unit of work. So if you think about the classic transfer, okay, I want to transfer some money from one account to another. It's really two discrete operations, a credit plus a debit. Right? So by having transactions, I can perform the credit and the debit as a single atomic unit of work, which ensures reliable results in my application. Because if I credit one account without debiting the other, then I've created money and I've created inaccurate results. Likewise, if I debit one account without crediting the other, then I've destroyed money, right? Which is never a good thing to do. Plus, it creates inaccurate results. Going forward, CommPlus will add on that existing functionality. So while you'll still be able to call set abort and set complete to signal whether or not you're happy with the results of your processing in a particular component, we also have a notion of autocomplete and auto abort, okay, which are attributes you can apply to a component. Okay, so that at the end of every method, instead of you having to explicitly get your object context and call set complete, the system will automatically call it for you. Okay? Likewise, if you raise an exception, instead of you having to call set abort, the system will automatically call it for you as well. So it just saves you that much more code that you have to write on a per method level invocation. Com Plus also adds compensating resource managers. So in order for a resource to be used in part of a transaction, it has to be transactional in itself, right? So SQL Server, Oracle, okay, these databases are transactional resources. However, there are many times that we want to use other resources that aren't necessarily transactional, like perhaps the file system, for example. Perhaps I want to save an image someplace on my file system, and I also want to save a pointer or a link to that resource in a database. But I don't want to do one without the other. I want to do them both as part of an atomic unit of work. Well, today, the file system is not transactional. Okay? But by using compensating resource managers, you can essentially rent log space in a log maintained by Com Plus and be notified of the various phases of the two-phase commit protocol so that you can use non-transactional resources in a transactional way. We also improved the interoperability. Okay, in MTS, you can use pretty much any XA-compliant resource manager. Going forward in Com Plus, we've expanded it to include Transaction Internet Protocol, which allows interoperability between heterogeneous transaction monitors. Okay. So for example, if you want to buy some goods and services from my website and someone else's website who may not be running Windows NT, how do you do that today? How do you do that in MTS? Okay, that's a very hard problem and a very real problem in the internet space, which is why the Transaction Internet Protocol becomes so important going forward. The ability to interoperate with other heterogeneous transaction managers across the internet. And that's managed by a process known as bring your own transaction. So you can start a transaction on one website and either push it to a secondary website that may not be running Com Plus, or you can pull that transaction from another website that may not be using Com Plus. Okay, so it's again the interoperability between heterogeneous transaction monitors. Because in the enterprise, and especially in the internet, everybody may not be running Windows NT. Right? So interoperability is extremely important in the enterprise. We've also got COM Transaction Integrator, okay, which allows you to execute CICS or IMS transactions on MVS systems from a Windows NT workstation. Okay, so again, interoperability is very key. When you think about interoperability, you want to think about interoperability of data, interoperability of applications, and also interoperability of other resources. So while XA gives you interoperability with resources, DCOM on Unix may give you interoperability with applications, as well as COM-TI. ADO and OLEDB, and even to some extent ODBC, gives you interoperability of data, as well as XML. And so again, interoperability is extremely important in a heterogeneous environment, which is typically the case in the enterprise and especially on the internet. If you're familiar with DCOM, you know about process access style security, right? Where I right click on a file kind of a thing. I can specify who can create a particular server, who has access to launch it, who has access to the various methods on an interface. That's all the way DCOM works. MTS works a little bit differently. MTS pioneered this notion of role-based security, okay? Which for those of you who aren't familiar, it's really two parts to role-based security. One that's a developer task, and the other that's an administrative task. The developer task, the developer's responsibility is to define the various roles, the various groups of users that can perform various operations in the application, and to control and gate access to those parts of the application based on those various user roles. So for example, administrators may be able to do anything in the application, while part-time users may be only able to do certain other things. So I'll define various roles: administrators, part-time user, full-time user. Then by making a simple API call, essentially, is caller and role, I can determine what particular role a caller is in. And then I can gate access to various application functionality based on that role. So that's the server's responsibility, that's the developer's responsibility to define those various roles. However, there's also an administrative aspect of it, which is once I deploy my application, okay, in a runtime environment, I need to actually map Windows NT user accounts into these various roles. So for example, Frank Redmond might be an administrator, so I will put that NT user account into the administrator's role. Somebody else, John Michael Groves, Paul Stafford, may be in the full-time user, right? They may be power users. So I'll put those Windows NT user accounts into the power user role. Then MTS will automatically check the credentials to make sure that those callers in the appropriate roles to access the application functionality. Going forward, COM+ will build on that by adding method level security. Today you can do it in MTS at the interface level. Going forward in COM+, you'll be able to apply security at the method level, including methods of iDispatch. Also today, MTS allows you to apply security, but only in a server application, which means that a group of components are running in their own separate process. So I have process isolation. Today, that's the only way you can apply security in MTS. Components must run in their own separate process. Going forward, in COM+, you'll be able to build on that, and you'll be able to apply security at the method level, even the components that are running in process with the caller. So we're going to extend on those basic functionalities of MTS in COM+ going forward. Also, since the system has the capability of flowing context automatically for the user, we can flow more security information from one caller to the next in an entire call chain, which allows the ultimate target object to find out a bunch more information from a security perspective on an entire chain of upstream callers, which is significantly important going forward. If you're familiar with COM, then you know that registration in COM is regedit. Okay? Well, MTS introduced this notion of the MTS Explorer, which was a graphical user interface that allowed me to do component registration, application configuration. It allowed me to do deployment and some basic monitoring. We'll continue to leverage that, and going forward, we'll build on that in COM+. We'll have the Component Services Explorer, which is an MMC snap-in that allows you to do all of those things that the MTS Explorer allows you to do. Plus, it will add in some of the functionality of OLE View and DCOM config. Okay, so you don't have to have a bunch of different admin tools to try to use and govern your applications. You can go to a single Component Services Explorer to govern and monitor all of your application services. The MTS Explorer is built on top of a basic object model, an admin object model that's fully scriptable. So you can write Visual Basic scripts or Java scripts that allow you to automate common tasks that administrators may need to do, such as adding users and things of that nature. So by having a fully scriptable admin model, it allows you to automate common processes. Also, many of the events, such as object creation, things of that nature, are logged, so you can measure and monitor the resources and what's going on with your application. It gives you more runtime information about what the application is doing from a performance perspective, which also allows you to build richer and developer tools so that developers can, again, get information about how the application is performing. Is it performing the way it's designed to perform? What are its limitations, hotspots, things of that nature? Things that can be improved, as well as things that are broken in the application. But that's not what everybody chooses to talk about COM+. Everybody wants to know about the new services, and that's really cool. Probably the most anticipated feature is queued components. So today, if you're familiar with COM, you're familiar with DCOM, you know that you can talk essentially via a synchronous RPC style call to a component from a remote location. And that's great. But what about a disconnected scenario? What about the roaming laptop user? Depending on who you talk to, as many as 40% of new PC sales are laptops, which means there's going to be a lot more roaming laptop users out there. So how do you develop component-based applications to facilitate this online and offline kind of operation? That's going to be a big challenge going forward. COM+ is the first step in that direction. It's the unification of essentially objects, transactions, and messaging. And what it allows me to do is, I still make interface method calls to a component. However, there's a special proxy involved. It's kind of a recorder proxy that records all of my interaction with that object. And it stores that interaction in a message on a local queue on my machine. So I can gather a bunch of information while I'm out in the field. I write the code the same way to drive objects, but that code is now being queued. That operation is now being queued on my local laptop. Then when I reconnect to the network, there are special listeners out there in the enterprise. MSMQ subsystem will automatically forward those messages to the appropriate queue in the enterprise, and those listeners will become aware of that information. And they'll pull one of those queues off of the message, one of those messages off of the queue, and they'll forward it to a special player, which is essentially a special stub. That stub will then unpackage that information and play it back and drive the target component directly. Okay, so think about recorders and players as essentially being specialized proxies and stubs in the COM+ environment. And they communicate via Microsoft Message Queue. And that's what allows you to have this single connected, disconnected programming model. The use of queues, or the introduction of queues between the client and the target component, ultimately increases the scalability of your application, because I can simply add more servers to process the work. So I never have a scenario where one server is idle and another one is swamped. Okay, the servers are constantly pulling work off of the queues and essentially processing it as fast as they can. So it gives you a true representation of truly dynamic load balancing. And never have a scenario where one server is swamped and another one is idle. Obviously, by being able to communicate with the local queue, which is always available, my component services are always available, because I can always communicate with the local queue on my machine. So it also increases your application's availability. There are some things you need to be aware of when you're programming in this disconnected, asynchronous kind of a model. Number one, since it's asynchronous, these are in-only method parameters, right? Out parameters just don't make sense in this model. The work is not going to be performed until sometime later, right? So you don't want to have synchronous operation in the client where you're waiting for an out parameter for some work that may not be done for a week, right? That's not good. So in parameters only. Think by value, no return values. However, we will support objects to support iPersistStream, okay, which means persistable objects. I can marshal entire objects into a single message, okay, across this network, which is highly efficient for remoting a bunch of information at once. You don't want to have a lot of different network round trips, as that kills application performance and ultimately scalability. Minimizing trips across the network is key to application scalability. So again, for the same reason that there are no out parameters, we don't have any application-specific H results, because again, the work may not be performed for some time in the future. It's deferred execution, and it's all possible because of Microsoft Message Queue. The next service we're going to talk about is events. Now, if you think about kind of a connection point scenario, connection points are designed for a very intimate one-to-one or very chatty kind of a handshaking scenario as a communications paradigm, which is completely different from a publish and subscribe metaphor, which is essentially one-way messaging. The server wants to notify any clients that are interested in the occurrence of certain events. For example, the disk being full. Also, the publisher doesn't really care who the subscribers are, potentially. Publish and subscribe is based on this simple metaphor where I'm interested in certain events and I register my interest in those events using some kind of administration tool. And that subscription goes into an events database. Then the server, when it notices that the disk is full, it fires a single event into the COM+ eventing infrastructure, which then iterates through the subscription database and notifies in parallel all of the subscribers. Okay, so late bound design, so that's going to be key. And the key point being that from the publisher's perspective, you fire one event regardless of how many subscribers there are. Whether there's 1 or 100, you're firing that event into the COM+ infrastructure, and the eventing infrastructure handles all of the iteration and the notification in parallel of the various subscribers. Again, this is a little bit different metaphor from the very intimate kind of conversation that you hold between connection points. This also means that the publisher and subscriber don't necessarily have to be alive at the same time. Their lifetimes don't need to overlap. Okay? When the COM+ eventing infrastructure fires the notification to the various subscribers, those subscribers can subscribe in one of two ways. They can provide a persistent transcription, which includes a class ID, at which point the infrastructure will co-create that class ID, query interface for the desired interface in question, and fire the appropriate method on that interface. Subscribers can also choose to implement transient subscriptions, in which case they simply supply an interface pointer, and then the eventing infrastructure calls on the interface that the subscriber has passed in. So subscribers have a choice of how they want to be, whether or not they want to be activated, and how their lifetimes will overlap. Transient subscriptions are only valid as long as the machine is alive. Okay, so if the machine is powered down and comes back up, that transient subscription is no longer there. Right? So the subscriber will have to do something else to make that subscription available again. However, in a persistent subscription, when the machine is powered off and powered back on, that class ID and all that information is stored in this subscription database. Right? So again, the client, the publisher, and the subscriber don't necessarily have to be alive at the same time, and is gated by whether or not the subscriber wants to have a persistent or a transient subscription. You can fire these events in one of two ways, synchronous or asynchronous. Okay? By default, you'll get the parallel synchronous event notification, or you can combine events with queued components to get an asynchronous, disconnected even, event delivery mechanism. Okay, so that's key. The events in this model are happening within the confines of a particular machine. How you choose to get off that machine out into the enterprise becomes an application-specific task. Okay? You can get off via DCOM, you can get off via queued components, asynchronous DCOM. Okay? There are many different ways to get off of the box. One of the common ways to get an asynchronous kind of delivery mechanism will be to combine or to compose events with queued components. And since the publisher is essentially only firing one event to the COM+ infrastructure, again, we have this limitation of in-only method parameters. Okay? Because if you have 100 different subscribers, which one of those are going to represent the out parameter? Okay? So it just doesn't make sense to have out parameters in this model. So again, think in parameters only. And also, there's a way to filter, okay, from the publisher's perspective as well as from the subscriber's perspective. So for example, while there may be many different stocks on the stock exchange, I may only be interested in the Microsoft stock, MSFT. So I can filter simply based on the data that's coming through for a particular event. I can filter on the stock name, I can filter on the stock price. Any of the pieces of information, any of the arguments or parameters that are supplied in the method call, I can filter on those different pieces of information. The next new service is load balancing for high availability. Load balancing works like this. You have essentially a group of machines that are configured to run a particular COM+ application. That group of machines is what we'll call an application cluster. Right? Any one of those machines are capable of running the application at any point in time. What then happens is when the client calls co-create instance on a particular component in that application, that call is intercepted by a load balancing router, which is a piece of software on a machine. That load balancing router then consults some information. In this case, out of the box, it'll consult a response time tracker, which is constantly in the background trying to essentially measure the response time for each one of these servers to a particular message. So think about the response time tracker in the background potentially pinging or sending a heartbeat message to the various servers in the application cluster and measuring their response time. How long does it take them to respond to the heartbeat? That's the information that it uses to try to gauge which one of those servers is least loaded. At that point in time, using that information, it will forward the co-create instance call to the least loaded server. A couple of key things about that. Load balancing is only occurring at object creation time. So it's not a scenario where a component is created on a server and then the load somehow changes and that component instance is moved. It's not like that. This component load balancing is only taking place at object creation time. Think about the load balancing router as essentially an enterprise-wide skunk, okay, in the sense that it's only involved in object instantiation. Once the object is created on a target server, the client is then given a direct connection, a direct interface pointer to that object, okay, and the response time tracker drops out of the picture. The client is then left to deal directly with the object and perform the basic lifetime management operations and interface navigations. The additional hardware increases your application's scalability and availability. Okay, as requests come in, you can gauge the response time of these various the various servers in the cluster and forward those calls there so that you can get these requests handled in a predefined response time. Some other key things to remember, that the load balancing is all transparent to the client. Okay, the client is simply calling co-create instance on a class ID asking for a particular interface. Transparently behind the scenes, the load balancing takes place. When you configure your application, that's when you tell it the load balancing router. That's when you point out the machine name of the load balancing router that you want to use. So this is all controlled via the Component Services Explorer. Out of the box, we'll provide the response time tracker. However, it's an extensible load balancing architecture, which means that you're free to plug in your own metrics for how you want to determine load balancing and how you want to balance the load for your various applications. The load balancing router immediately sticks out as the potential single point of failure in your DNA or your distributed application design, which is why you should cluster load balancing routers with Microsoft Cluster Server, okay, to increase availability and essentially eliminate the load balancing router as the single point of failure in your design. The last new service that we're really going to take a look at is the in-memory database. So many times you have access, or you need to access information frequently, right? Frequently accessed information, you want to keep it as close to your application as possible, preferably in process, if it's at all possible. That's exactly what the in-memory database is designed to do, to provide in-process access to cached data. Okay, so frequently used information, keep it as close to your application as possible. You can load these tables at startup, so kind of a pre-configured way, or dynamically upon request. So the in-memory database is sitting on top of any database management system out there. And that information, the various tables that are in that database, can be populated up into the in-memory database. In the client's process space, they get a memory map of that information so that it's directly in your process space and you can access it. Accesses are extremely fast since it's in process. And again, the in-memory database automatically builds these indexes so you can do sorts and filters and things of this nature. It's accessed as an ADO or OLADB simple provider, which means there's no query processor in version 1. Okay, so again, think ISAM style access. Think indexes. That's how a memory database will be used initially in version 1. At some point in time, it is our intention to provide a query processor if that makes sense. The in-memory database will work with regular 32-bit memory access, but also if you have a machine with 64-bit memory access on NT5 or on some boxes on NT4 on Alpha, you can take advantage of that full 64-bit memory access transparently by using the in-memory database. Fully transactional memory resident database, so it participates in automatic transaction enlistment, okay, just like any other good resource manager would. Automatic transactions, again, pioneered by MTS, going forward with COM+. It provides all of the sophisticated lock management process, provides concurrency and isolation, things you would expect from a normal database, except without the disk and without the query processor. And again, since the programming model is ADO or ADB, there's not a lot more to do from a code perspective. This is, again, more administrative. This is all configured using the Component Services Explorer. Again, think more about that attribute-based kind of programming model. Okay. The code you should be writing, we want to minimize the code you have to write just to get your application to perform. We want that code to be targeted toward solving business problems. So in that model, with these new services, what does the COM+ programming model look like? Well, application servers are simply responsible for defining their functionality as interfaces and implementing those interfaces as COM classes. As part of that implementation, you're writing code and you're using these various COM+ services. You're using the in-memory database, the eventing system, queued components, load balancing, transactions. Okay? You're using these system-provided services to perform your business operations. Application clients, they have it a lot easier. They co-create on COM classes, query interface with various interfaces, call methods to have application work performed, and then they release those interfaces when they're done. Okay, so clients have it a lot easier in that model. But again, COM+ is targeted toward making it easier to develop these highly scalable, highly available servers. Okay? You don't have to worry about all the complexity of multi-threaded code and handling concurrency, semaphores and mutexes and things of that nature. Instead of focusing on that, put your effort into the business logic that solves the problems your application is designed to target. The benefits are reduced APIs. Okay? Create instance on a component, I perform some work. If everything went well, I call set complete. If things went haywire, things went south, I call set abort. And the context of that information is flowed from one component to the next. Context is various environment, runtime kind of attributes, the security, the context of the caller, okay? Security information, transactional requirements. Okay? All that information is part of your context. It's part of your environment. So reduced APIs is one of the benefits of this. Instead of introducing more and more APIs as we introduce more and more functionality into the component services, we want to introduce more attributes and more point and click kind of a programming model. And again, you're writing code to solve specific business problems. You can make checkbox attributes and things of this nature via the Component Services Explorer, and in the future going forward with new development tools to declare whether or not you want transactional support, whether or not your component requires a transaction, whether or not your application has a load balancing router, okay, the configuration of the in-memory database, or the configuration of other services will be provided and administered via the Component Services Explorer, and again, going forward with additional tool support. We also want to strive for zero plumbing. Instead of you having to write some of these services yourself, instead of you having to write a TP monitor, instead of you having to write a high-speed access management system like in-memory database, or instead of you having to write a publish and subscribe eventing architecture, we want to provide those services for you. So again, we can minimize the amount of plumbing you have to write just to support your distributed applications. What does this mean going forward? What this means is we're going to continue to enhance and expand the various application services, object persistence, workflow, things of this nature, high availability. We're going to continue to expand and implement new services that you as application developers can target. So again, that's less infrastructure that you'll have to write. We're going to continue to improve administration. Okay? Administration is a huge thing, a huge problem in the enterprise. As you have these components on various servers in the enterprise, how do you control them? How do you configure them? How do you deploy distributed component-based applications? Right? How do you make sure that your application is performing as you expect it? Okay? We're going to continue to try to improve administration of these applications. And also, obviously, we want to make component development easier. Okay, Visual Basic is going a long way in making that happen. Okay? We want to take essentially the best of those kind of features and some more additional ones and push that down into the operating system so that all languages can take advantage of it, so that all languages can take advantage of this more attribute-based style of programming. So we're going to provide additional runtime services that tools developers can target, okay, to make it easier for you to develop component-based applications in your tool of choice. Tighter integration with developer tools, end-to-end debugging, things of this nature. Okay? We want to make it easier to develop, deploy, monitor, configure these component-based applications going forward. Kind of the summary of all of this, what's all of this about? COM+ is part of Windows 2000. Okay? It's a key part of the operating system. Going forward, you should know that all of your existing investment in COM and MTS is 100% compatible going forward with COM+. All COM objects will become COM+ objects. All MTS packages will become COM+ applications. Think of these COM+ services as an incremental additive investment. If you don't need eventing, you don't have to use it. There's a bunch of different services there that you can pick from that makes sense to use in your application to reduce the amount of APIs you have to learn, to reduce the amount of code you have to write. Okay, we're going to continue to expand that range, that smorgasbord of services that we'll provide, and you as developers can simply pick from the ones that make sense for your application. The key point of all of this obviously being focus on solving your business problems and let us worry about the plumbing. Okay? That's less code that you have to carry forward and migrate going forward, less code you have to test, faster time to market, everything like that figures into that. Focus on your business logic, okay, and let us do the plumbing. That's the other key takeaway from this. There's a bunch of other services in COM+, a bunch of other niceties that you'll find quite nice actually. I encourage you to go up to the COM+ booth. We got a MTS COM+ booth in the exhibit hall, where we'll be able to have more demos and things of that nature. This is a basic introduction. We wanted to take the intro out of each of the various sessions at TechEd. So now that you have a basic overview of what the services are and kind of how they fit together, as you go to some of these other sessions, you'll be able to get some more detail on how events work or how in-memory database works, okay? How some of these other services work in great detail. So again, stop by the back, get your limited edition COM+ resource CD. And other than that, I'll take some questions, anything you may have heard, anything that's confusing, anything that doesn't make sense here. And other than that, I thank you for sitting still and enjoy the rest of TechEd. Thank you. Raise your hand, I can't see you.
I got a question.
All right.
We're using Windows Load Balancing Service right now and doing testing. Are you referring to the load balancing in COM+ to use WLBS?
No, okay, so there's two kind of ways to load balance in Windows 2000 going forward. Windows Load Balancing Service does essentially IP load balancing.
Right.
Okay. COM+ load balancing does component load balancing. So on component creation, we're going to balance the load like that on component activations.
Okay. In the documentation in WLBS, they separate it out. So the first tier is WLBS, second tier COM+, and the third tier Microsoft Cluster Server or the data tier. Okay.
Sure.
So you're saying there is some type of specific in the middle tier, some type of router software that is doing load balancing. Where can I get more information on that? It's on that.
It's on this CD, and also if you stop by the exhibit hall, the Compost booth in the exhibit hall, you'll be able to see how all that stuff is administered and see some demos and things like that.
And there's all types of documentation on ComPlus because
Sure.
there's nothing in MSDN yet.
And also look on as part of the conference, you'll receive a Windows 2000 CD, beta. So on the SDK that accompanies that, you'll find out more information about that. The specific diagram that you're referring to has essentially, I'm assuming, HTML clients coming via ASP and that's balanced via Windows load balancing server.
Right.
So you have some kind of client affinity there based on the IP address of the client. Then once you get onto that server, that ASP server is going to co-create on some COM objects to perform its business operations. Well, from that particular server, you might have a variety of different back-end application servers from a COM Plus perspective to handle those requests.
Thank you very much.
In the discussion of events,
Yes.
I thought I understood you to say the events could be synchronous or asynchronous.
Yes, sir.
What does that mean? Is that happening at post time, at subscribe time, and what's it mean to have a synchronous event?
Okay, so the question is referring to the synchronous or asynchronous delivery of the event mechanisms in COM Plus events. Okay, what that means is if I have a specific line of code in my server, do some work and disk full, or notify disk full or something of that nature. Okay. When I call notify disk full when I fire that event into the COM Plus eventing infrastructure, at that point in time, the eventing infrastructure will in parallel notify the various subscribers. Okay, it's synchronous from the perspective of my application code, from the perspective that the line of code after that won't execute until the last subscriber is notified. Okay, so that's the synchronous event mechanism. Asynchronously is if I'm firing those events and I'm firing them, the COM Plus infrastructure, okay, if that class ID or the interface that's registered as part of the subscription, if that target object is accessible via or configured to use queued components, then obviously the queued components then provides the asynchronous aspect of that delivery. You're welcome.
Yeah, I have a question about the role-based security.
Sure.
We're an ISV. We ship an application where our customers design the roles and make decisions about who's playing what roles.
Sure.
Do you have the mechanisms that allow us to abstract that decision and bind it late?
Not at this point in time. That's something, a feature that we've been getting a lot of requests for lately. We're taking that information into concern and consideration. It's probably not going to happen until post-Windows 2000, however.
Okay, I have another related question, or not that related, but also related to being an ISV and having to need those levels of abstraction. When you queue a message to a COM object using the queuing service, do you have ability to manipulate? I'm thinking about the disconnected model, where the two applications, someone's been disconnected, we now want to put them back together. We actually need to examine both queues, the queues that are going to go down to the remote user and the queue that's going to come up to the main server, and look and see if there's any conflicts and resolve the conflicts. That is, they both change something, the same thing. So we want to do some kind of conflict resolution before we just let the messages flow. Do I have the ability to manipulate the queue that way?
Well, I want to make sure I'm understanding what you're saying. I think there's some confusion as far as ultimately there's only one target queue, right? So what happens is on your local machine, the information that's destined for that target queue that may reside in the enterprise will be replicated on your machine, and that information will be queued up, that work will be queued up, then transparently forwarded to the other queue. So there's never a way really right in there for you to intercept that call.
Well, while they've been disconnected, things have been happening to the main server.
The database, are you referring to like the database server or?
That's right, wherever the main, the sort of the gold standard for the information.
Okay.
And so when they go back together, the information has to flow both ways. The things that have happened. And so it seems like what you need to do is look at, or at least in our application, you need to look at both queues and say, is there any place where the thing's been changed in both places?
Okay, so essentially there's really only one queue, I guess is my point. There's really only there's really only one target destination queue that you're shooting for. Once your component receives this message that a client wants to somehow change or manipulate, update some data, at that point in time, you'll want to go look into the database or whatever you want to do there. But in between MSMQ actually storing those requests and then forwarding those messages, there's no way for you to do that directly within the queued components framework. If you wanted to do something like that, you'd have to develop your own kind of custom proxies and stubs, your own kind of custom recorders and players.
Thank you.
You're welcome.
Hi.
Hi.
I have a question about the in-memory database, and you were talking about automatic transactions. Is that so? Say I put a table in this in-memory database on another server. That's going to keep that in sync with my database server now with transactional integrity?
Okay, so kind of what happens is at this point in time, the in-memory database is a single node architecture. And so it's working on a single machine. And that information is essentially, in-memory database has to be the sole controller of the database resource, okay? Because in-memory database is going to push information down into the database. There's no way for if someone comes in the side, makes a modification to percolate that information up.
Back to the person. Okay,
Right,
so
right.
it doesn't work that way.
Right, so in-memory database on a single machine is sitting on top of your relational database management system. You're making modifications and updates to the in-memory database, right, as part of a atomic unit of work, as part of a transaction. So obviously it will enlist in that transaction to make sure that that's happening in a consistent, atomic, isolated, durable, well not durable in this case, but isolated manner, right? And then once that transaction has committed, in the background, in-memory database will push that information down into the underlying database management system.
I guess I'm struggling with how's that different than just SQL Server's caching.
Okay, so one of the ways it's different is, number one, the in-memory database is taking a memory map representation of the data that's in these tables and mapping it directly into each individual caller's process space, right? So essentially what is made for essentially really read-only data that's going to be read very frequently, right? So I can cache that right in my process. I don't have to necessarily pay a context switch to get to that information. I definitely don't have to jump out of the process to go get that information, right? So think about information that you would potentially put in the database to perform lookups and things of this nature, right? So what happens is whenever you start to write very frequently to that data, what has to happen is all of the in-memory database, all of the in-memory representations, all the memory map representations of that data have to be locked. The lock manager then has to synchronize access, so on and so forth, to the information, as well as write it to the underlying data store. Right? So again, it's kind of like, think about SQL Server pin tables, for example. Except that, again, this information is going to be mapped directly into your address space.
Okay, so it's taking this pin table and then distributing it out to these multiple clients.
To multiple clients directly into their address space.
Okay, thanks.
Hi. I have two questions. First one, could you point to a specification document for COMS Plus?
In terms of like the COM SDK on the Microsoft website or something of that nature?
I'm thinking compare with the COBAs. COBAs like specs from OMG define the service specification.
Okay, well, the specification is not necessarily a specification, all-encompassing specification. What we've done is describe the individual services. You can find out specifications for the individual services from the COM website, so microsoft.com/com. A lot of that information and comparative analysis and comparative information with Corba is also on this CD, and there are other resources listed on the CD, and you might want to take a look at that.
Okay. And it seems to appear to me right now that the COMPAS moving to a similar pair compare with the COBA. How do they compare with the COBA's architecture in terms of embedded service?
I'm not really actually that fluent in the Corba services, so I really couldn't answer that question. I'm not that fluent in what Corba provides, and I know obviously what Microsoft provides. I'm not as familiar with what Corba provides, so I'm sorry, I'm not really. I can't really answer that question.
Does COMS Plus provide a naming service also?
So the COM Plus naming service is based on, we've expanded the naming service that we have to obviously take advantage of the directory services. So for example, if you have a particular component in the enterprise identified by a class ID that you want to access, What will happen is when you try to instantiate that object, it'll look on your local machine to see if it has a local copy, right? So that it doesn't have to go across the network to access that information. If, however, you don't have a local copy, it will automatically consult the directory service to find the location of that class ID on a particular server somewhere in the enterprise, and then it will use that information in the directory to actually create that object instance on that particular machine and bind the client to that instance.
So basically, it's based on the directory service instead of a separate. There's no a separate naming service
Right.
for COM+.
Right. So it's all based on the directory service information, and the way COM does it is with GUIDs, class identifiers, and you can use that to provide. You can provide human readable versions of that via monikers and things of this nature. So really, monikers and class IDs combined with the directory service in Windows 2000 comprise to make up COM+'s directory naming scheme.
All right. Thank you.
Are there any plans to implement object pooling within MTS similar to data connection pooling?
Good question. So object pooling is another one of those services that's actually available in COM+. So you can find out more information about that, again, on the CD here that's available in the back, or up at in the exhibit hall at the COM+ booth. You can find out a bunch more information there. We got the SDKs loaded there. You can see sample code, things of that nature, all available up there. So yes, object pooling is available in COM+. However, what I do want to say about that is object pooling is not typically something that we see people using for general object construction or for typical business objects like the account object or something of that nature, but more as an alternative to resource dispensers, simply because of some of the threading semantics that have to take place there. So this is not something that will be used in the general case for, the customer account object or something of that nature. Okay.
With remote data services and COM, there's an issue with security.
Sure.
And I was wondering if that's going to be addressed in COM+.
Yep, and in fact, I believe there's a knowledge base written up on it, and you can again check that information out. We've got MSDN and all that information loaded upstairs in the COM+ exhibit hall, and you can, I think, actually just search for RDS and MTS, and you'll find a knowledge base article written up on that. You're welcome.
You said COM+ or COM objects become COM+ and packages become applications.
Kind of a terminology. Well,
Right.
the packages and applications is kind of a terminology.
Is there any compiling or anything you have to do? You just
No recompiling necessary, which is obviously one of the benefits of COM. No recompile necessary. However, to take advantage of some of the new services, you'll obviously have to do some new things. But you'll use existing tools to target all of these new services that I've talked about today. Going forward, as we introduce more services and provide more runtime information available, the tools vendors will be able to take advantage of that and propagate that information up and make it easier to expose that in the development tool of your choice. Okay.
Is COM+ going to be able to support stateful objects unlike MTS?
Okay, so the whole stateful versus stateless discussion. So MTS is really designed for flyweight objects, right? It's really designed you really have to think about separating out state from operations. And that's really one of the key ways to get scalability, right? Is to recycle something. It's typically cheaper to recycle something than to create a new one, right? So that's kind of the whole metaphor behind the way MTS caches and recycles objects, caches DLLs, caches class factories, everything like that, because it's typically always cheaper to recycle something than to create a new one. So again, the whole premise behind the quote-unquote stateless design is to maximize scalability, and as a developer, you must separate state from operations. Going forward, that is still a paradigm in COM+. However, that's not to say that in MTS you can't have stateful objects. You can have stateful objects. You mark them as does not support transactions, and they'll behave just like any other object you would expect. They'll be long-lived. However, you also must recognize that they won't be recycled, they won't be cached, things of that nature. So you can have stateful or stateless objects in MTS today. Going forward, you can have stateful or stateless objects in COM+ going forward. It's really a matter of achieving scalability. And we can talk more about that offline if you want some more information about, again, the key being separating state from operations.
I have a question about the event in COM+. You mentioned that the publisher doesn't have to know about the subscriber.
Sure.
It's also true in the other ways, right?
Right. So, however, it's true from the perspective that the subscriber doesn't necessarily have to know who the particular publisher is, but they obviously have to know the event that they want to subscribe to.
Understand. Okay.
Any other questions? If you have any other questions, feel free to come up and ask directly, and we can take some time and talk about them. If not, again, I thank you for sitting still, and I will be tuning out.